But when you're looking at the radiation characteristics, it's the radiative field that gets interesting, because all these cars that you're communicating with the car, is all going to be in the far field, yeah? So the radiation characteristics of the antenna, there are two things that to be considered. One is the radiation pattern, and the other one is the polarization of the antenna. The radiation pattern, as the name says, is that how this antenna radiates in space. It could be radiating strongly in one direction, weakly in some other direction, or it could be radiating the same in all the directions. So it's important to understand the radiation and then use the antenna appropriately for the suitable application that you are looking at. What this antenna radiates is electric and magnetic fields in terms of a vector. And if these are radiating in spherical coordinates, what you see as spherical coordinates, you have r, theta, and phi. The components that you see here can have a theta component, phi component, and a radial r component. When you are in the far field, the radial r component is 0. It's only the theta component and the phi component exist. That means as the antenna radiates out as a sphere, the only electric field components are on the surface now, not in the direction of propagation. As this guy radiates out, you have no component in this direction. This is the direction of propagation. You only have components that are tangential to the surface, which is theta and phi. You can have theta and phi components. Now, if I were to take the magnitude of E over H, it is like the magnitude of voltage over current, so that the intrinsic impedance, and that for free space or air, is given as 377 ohms. You have your mu naught, which is 4 pi into 10 power minus 7. You have your epsilon naught, which is 8.854 into 10 power minus 12. You take the ratio, take the square root, you will get 377 ohms. So this is the characteristic impedance of air, yeah? In that sense, it's the intrinsic impedance of air. So in that sense, you can imagine what an antenna does is when you have a 50 ohm line, this antenna, you can think of it, you can visualize it, you can imagine it to be a matching network that matches this 50 ohm impedance to 377 ohms. If it does a very good job of matching, then the antenna perfectly behaves well and is able to radiate all the power that is supposed to radiate, yeah, that is fed to it. So instead of looking at the field, theta and phi, as engineers, we don't want to look at the field. Instead, we look at the power, which is essentially E cross H, yeah. But so that it's like voltage times current. So that pattern is what is called as power pattern, and it is expressed in dB. Remember, this pattern is a three-dimensional, yeah, is a three-dimensional pattern. And it captures how this antenna radiates energy in different directions.